Hello, this is the 6th video for Graphs and Networks Series 3 on Further Graph Theory for OCR Discrete Further Mathematics, and we'll look at the thickness of a graph. The thickness of a graph G is the minimum number of planar graphs into which the edges of G can be partitioned. By partitioned, we mean split up into layers. Think of microelectric chips. So a planar graph has a thickness of 1, and a non-planar graph has a thickness greater than 1. This makes sense because a planar graph needs no partitioning. But if we are not allowed crossings, then we do need more than one planar layer for non-planar graphs. You do not need to calculate thicknesses in general, but it is helpful to recognize some common examples. Here is K5 that we looked at in previous videos. It's a non-planar graph and it has a thickness of 2. You'll remember that we could draw most of it until we realized that it was non-planar. We just needed that last extra edge that we couldn't add without creating crossings, seen here as BD. Obviously, there is more than one way to layer this particular graph into two planar graphs. And we can see that the minimum number of layers required is related to the thickness. Note that we need to keep track of the number of arcs required. In this example, we knew that it was 5 times 4 divided by 2, or 10 arcs, of which 9 had to be drawn without any crossings, leaving us just 1 required in the additional layer. For the Peterson graph, we have 10 nodes, each of order 3, which we can look at by inspecting the graph. Counting the edges can sometimes become a little confusing, but if we work out 3 times 10 divided by 2, we know that we're going to be trying to draw 15 arcs in total. We've managed to draw 12 arcs without any crossings, which would give us the first layer. This means that we know we have got to put 3 arcs into the second layer. So let's put in that arc there, and then we know we need to connect this node to this one. We don't want any crossings, so we can put it in as a curved arc. So 2 layers means that this Peterson graph is also of thickness 2. In this example, we meet K33 yet again, and we know that we could draw it in this isomorphic form. We know that we have 6 nodes and a total of 9 arcs. Here we obviously have some arcs crossing. However, we can draw 7 of those 9 arcs without any crossings, leaving therefore 2 arcs that will need to be in the next layer. So, for example, that arc there, and then realizing that we need to go across, we'll go in effect go around to avoid a crossing, and that arc there. Thus K33 requires a minimum of 2 layers and has a thickness of 2. In summary, all planar graphs have thickness of 1. All non-planar graphs must have a thickness greater than 1. If we can draw the edges of a graph in k layers that each contain no crossing edges, then the thickness must be less than or equal to k. Hence, in cases when we can redraw a non-planar graph in 2 layers, we can conclude that the thickness equals 2. This is the final video of the Graph and Network 3 series.